I'm in my third year of college. I'm so excited about the new GETT video series. My favorite STEM subjects to study are chemistry and biology, and I also really like to draw and paint about science. I'm currently a chemistry major at Brown University, and I'm also going to medical school in New York City to become a doctor who takes care of babies. The fancy name for that is a neonatologist. Happy 20th anniversary, GETT!
Hello, my name is Dr. Annie Jung, and I'm here at the American Helicopter Museum and Education Center in Westchester. Today we're going to do an experiment to learn about hydro and aerodynamics, which is the properties of how air and fluids move. And so have you ever wondered how an airplane or a helicopter can take off and stay in the air? It has something to do with a principle called Bernoulli's principle. Even though we can't see air that's around us, it's always putting pressure or force on everything in it. And so with Bernoulli's principle, it says that the speed or the velocity of air changes how much pressure it puts on an object. And this might be really confusing. So let's do an experiment to see what that means.
So to do this experiment, you'll just need 2 empty soda cans, some string, a little bit of tape, a pair of scissors, something to hang your cans on, a ruler, and then a fan or a hair dryer, something to actually move the cans.
Right now, the air around both of these cans are moving at the same speed and direction, and so there's equal pressure around all sides of the cans, and so they're not moving. Imagine if you were standing in a circle with 5 of your friends, and there was a ball in the middle that you all were pushing on at the same time. That ball wouldn't go anywhere, and so it's the same thing that's happening with the cans and the air. Next, we'll use a hair dryer to blow air between the cans and see what happens.
So as you saw, when the hair dryer was blowing, the cans actually moved together and touched each other. Now, it may seem like that was due to the hair dryer, but as the really, really fast air went down the center in between these 2 cans, the slower moving air on the outside of the cans created more pressure and forced them together. As you can see, over the years, aerospace engineers have studied this principle and how helicopters work. You can see how the number, shape, and position of the blades differ, and even how the bodies of the helicopters all look different from each other.
Hi, I'm Julianne Bowers, a Program Quality Manager at Sikorsky Aircraft, a division of Lockheed Martin, and also a trustee for the American Helicopter Museum. I have been a part of GETT for several years because it's super fun and I really like all the activities that we get to see from other companies and also sharing some of the cool stuff about what we do. In my job, we use engineering data, aerospace science, and math together to help keep the aircraft safe and come up with ways to improve things. It's really fun because we get to use a lot of different aspects of STEM to do what we do. In my role for the museum, we come up with ways to share about the history and also to share the STEM and the science behind how the helicopters work and the engineering. My background, I had no idea that quality was even a job or that I was interested in aviation. And I was also an introvert and super shy. So if somebody had told me then that I was going to be a manager, I would have said no way. So my advice to girls looking into a career in STEM is be open to anything. There's a lot of really cool stuff out there that you probably haven't even heard about yet. And GETT is just one of the ways to learn about all those things that are out there. Happy 20th anniversary to GETT.
Hi, my name's Dr. Amber Stuver, and I'm a physicist from Villanova University. Specifically, I study astronomy. I study how the universe works, and I try to make new observations. I am especially interested in things like black holes, and a new way of observing them is with gravitational waves. And the experiment that I work on is called LIGO, so LIGO, for Laser Interferometer Gravitational Wave Observatory. But I teach students who are interested in all sorts of different aspects of science, from students who want to become medical doctors, from students who are just a little bit interested in science, to students who want to be physicists and engineers. And it is a deep understanding of physics that makes it possible for engineers to build helicopters like the one I'm sitting in right here. In order to get to where I am now, I needed to study science in high school. I went and I majored in physics whenever I was in college. And while I was in college, I realized that I wanted to continue my education in physics instead of going and directly getting a job. And so I went to something called graduate school. And graduate school is a lot like med school, but for people who don't want to be medical doctors. It's what you do next after you're done with college. And so I did that, and I ended up getting to do all sorts of things and traveling the world to talk with other scientists. And now I make my home outside of Philadelphia, and I get to work with the wonderful American Helicopter Museum and Education Center. And that's why I have this amazing opportunity to get to talk to you. So thank you very much for listening.